Thank you very much. This is us in Carson City, Nevada, and we've been in this facility since 1987. We built it especially for our business, moved from Palo Alto, where we were there from 1947 through 87. And so this is our home. Inside the home is a little picture of inside. Some of these, we have lots of screw machines. It's doing high-speed cutoffs. We have lots of CNC equipment as well. And then the back is a lot of other things that do the powder metal seats and so forth. So we're proud of the facility. We'll have a little more on that as we go forward. So first of all, the fellow that you saw in there before, I have to correct him a little bit. He said it's been in business almost 60 years. He was a little behind. I think it's almost 70 years actually right now. So we do powder metal valve seats, cam bearings, spring booster shims, hardware, and we've got a number of international recognized pieces like the ISO and Oliver White certificates.
Yes, and all of that proudly manufactured in the United States of America.
Everything is made in America. And at the bottom, you'll see our little guy whose name is George. He's our little mascot, and he has a American flag everywhere. So you get.
You know, the only thing I don't understand, Chuck, the only thing I don't understand, you were last with us like 5 years ago, right? And George doesn't look like he's any older. He looks exactly the same as he did 5 years ago.
He does. Yeah, he's the guy that has been around with us since 1947.
That's
amazing.
Crazy. It is amazing.
So I guess one of the questions is on bearings. Well, why use bearings at all? And actually, you'll find in some applications going forward, particularly overhead cam, and some even in cam applications, the OEs are trying to eliminate a cam bearing and actually run on the material itself, the head material. That's cost savings, of course, but as we know, a bearing is much better than having it run on a cast piece. So we want to have it survive the metal-to-metal conditions, embed, which the habit certainly does, any foreign particles that comes through, and it also conforms to the geometry and provides a sacrificial wear surface. So any engine block that's made in OE is typically put together with semi-finished bearings, and then they're line board. That's the best that there could be. After that, it's a matter of some compromises. So with compromises using Babbitt and the bearings that we have, it makes it so it works in the rebuilding scenario. There's a number of different materials that are available out there. There's copper lead, it's high cost. There's tri-metals, very high cost. Aluminum tin, sometimes that will make things possibly, if there's a problem, the bearings spin. And then there's white metals, and white metals is what we use, which we call Babbitt. It's a lower cost. It has an excellent soft phase so that it will embed, and it'll also take care of the different pieces within the cam bores to make sure the cam go in it and it will turn. So when we're talking about cams and cam bearings, the whole thing with cams and cam bearings is that you want to have a wedge of oil that goes underneath the cam, and so that wedge of oil goes up and around counterclockwise, and it will make that a little bit of a wedge underneath the cam, and that it will actually lift the cam, and the cam will actually be floating on a wedge of oil. So there's no cam bearing material actually there at that point once it lifts. Problem can be sometimes as you have dry start and you don't have the oil there, that can cause problems of wear within the cam bearings right off the bat. But the whole point, again, is to lift the cam on a wedge of oil, and that wedge of oil goes hydrodynamic, and it keeps that cam floating on that, and then there's no problems. With Dura-Bond, we make quite a different type of product than the original equipment or any others that might be out there in some other parts of the world. We make it 100% machine surface. We have the tightest tolerances in the industry. When we have a cam bearing, it looks like a piece of jewelry because we centerless grind the ODs, we centerless bore the IDs, and as you can see, the wall tolerances are 5/10,000ths. Given the customer increased design flexibility, we can do both high and low volumes, and we're strategic partners with lots of different folks. But it's a unique product that no one else has, and that's why we've been by far the most recognized cam bearing in use in the world. We have great delivery. As you know, we deliver to you about 95% on-time delivery and coverage. We have technical design people in-house. So we do a number of things which we learn mainly from customers about ways that we can improve and enhance by using OD grooves and enhance the oiling, larger ODs to save a block, smaller IDs to improve oil pressure after those blocks have been redone a number of times. We have some that are wider positions, like in the N7s, to reduce oil leakage. I have ID grooves to improve oiling, reduce oil holes and relocate, improve oiling, and overhead cam repair bearings. Some common conditions that cause bearing failure are certainly foreign particles in the lubricant. The geometry becomes off sometimes in the cam bores. The extended transition period to go hydrodynamic. As we said, if an engine's been sitting for a period of time, it needs to get the oil up there. And if you haven't primed it or got the oil up there, that can be a problem. Thickened lubricants, incorrect lubricant viscosity, lubricant dilution, meaning maybe possibly you've got overload of gas that goes in the crankcase, overloading, shaft and housing deformation, corrosion, and incompatible materials. This is an interesting piece, and it's in our catalog as well. This is a bulletin put out by AERA, and it's a question that comes up with a lot of different folks over time. And again, it talks about the hydrodynamic wedge, but it also talks about where the holes should be best aligned in the cam bearings. There's a little chart here that you can see that if it has a groove, you can use it at the best place for the hole is about 60 degrees. And if it does not have a groove, then the hole has to be lined up, of course, with the block. So a lot of people try to put it in different positions, but again, the best place is to have it about 60 degrees if it has a groove. And what that's doing is helping with that, building that hydrodynamic wedge so that it's going to run on that film.
I trust that yours are at 60 degrees.
Yes, we're always, well, you're clocking it at 60 degrees in the block.
Got it.
That's a manual piece that you're doing.
Oh, I understand what you're saying. Yeah, because yours is the oil hose is then clocked at 60 degrees. Got it.
That's right. Your machinist is clocking it at that. And that comes up many times as questions on the tech line. So we have mentioned oversized, undersized bearings. We have semi-finished bearings. If people do want to do line boring, that's available as well. We have the high performance bearings, which we have in a red box. And the great thing about that red box is that it does give you that extra level of protection if you've got extra spring pressure or you have a dry start. And for the salespeople, you know, our regular blue box does a great job. But, you know, as you're building an engine, a bill of material for somebody, and you're asking them the questions to say, hey, what is it that you're building? And so they say, well, I got some dome pistons, you got a little extra spring pressure, you got a little high lift cam, and so as your compatible products over the counter to them, this particular product is the product that should go with anything that's an upgraded race type of performance piece. So what it's doing is it's protecting against higher spring pressures, and it's also in the coated side protecting against that, and also a thermal barrier for dry startups. So it's really a great piece, and it's a piece that you can make more money on. It's a great piece that's deserving to be part of the build, and it should be a standard for anything that you do that's a little bit of uptick for a high performance street rod or above that. We do.
I got a question. This is Daryl in Oklahoma City. Hey, the last two slides you showed are great slides, except there's no detail on either one of them. Like the first one, you know, was the information about the offer oversizes. And the catalog is not very clear a lot of times based on what the oversize is at the end of the number. There's sometimes a letter at the end of the part number that stands for something. It would be helpful to have something that shows what an oversized means, whether it's an oversized bearing, it's undersized, you know, for the crank, for the cam, I'm sorry, or, you know, however that bearing is designed to accommodate the cam or the block. Because sometimes it's very confusing whether the oversize is for the cam or for the block, and vice versa with the whatever the suffix may be at the end of the part number. Same thing on the performance side of it here. More detail on what the performance bearings fit. There is a section in the catalog, but it's very limited, and you know there's not a lot of detail on many blocks that are out there that y'all offer bearings for. Okay, anyway, I just thought I'd throw that out.
I think that's a great piece to go forward with, and I've got some more detail as we go through this. May help answer those questions, and if there's more, we can certainly do that as well. So thank you for the question.
Yeah, great. Thank you for the comments, Daryl.
Just back to the coatings for a minute. It's a black appearance. It's 3/10,000ths of the thickness on it. Operating temperature up to 500 degrees. Reduces dry starts, takes care of abrasion, retains oil, and reduces bearing temperature, increases fatigue life.
And Chuck, you folks use Calico then for your coatings?
Yes. Yes, right. We have for many years. And they do a great job.
Interestingly, we had the EPWI folks with us just a couple of weeks ago, and they've just changed to Calico. And I think they used, who was it, Elliott? They used previously. They've now gone to Calico. But Calico is well established and been around a long time and know what they're doing.
Yep, yep. And the racing side, they're really good with that. In this particular one, we're talking about enhanced engineering solutions, and we kind of talked about some of that before. And Daryl, your questions there in the bottom, the redesign, the aftermarket. We have some that has like B12B, and the B afterwards is an OD groove, and we'll go into some more details to that. So there's OD grooves, oversized bearings, undersized, semi-finished, and let's see if I can give you some more details of how to identify those. So here's a piece out of the catalog, and this just goes to show you all the different types of things that are available. So you take a CH8. So there's a CH8, which is the standard piece, and you see it's CH8 there. Next column over is a CHP8, which is the high performance, and then the CHP8T coated. So then if you wanted to go down below, you can see the oversize on the OD, which goes to a CH4A, and that's also available if they need an oversize to fix a block. Are that available in regular high performance and coated, and that goes for 10 thousandths over, 20 thousandths over, 30 thousandths over, 40 thousandths over. So they've got every combination that you can possibly have. The last one there shows a CH8W. Now the W would say that it's an undersize, And so it's a 1,000th undersize in the ID. So what happens on that particular type of application is you have somebody that's polished the cam or done something with the cam over time. The cam is a little bit different in size. So what we're trying to do is adjust it, make it a little bit more meat, so to say, on ID, and that tightens it up against the cam, and that's going to give you more oil pressure. So that's sometimes a complaint when that engine's just been built too many times or somebody's done something with the cam to polish it up. So those are some pieces that may help to explain some, maybe not all, of the things that Daryl was asking about in the...
So basically you've got the standard part number or standard bearing, CHA. If you add an H, that's going to designate high performance. If it has a T suffix, it's going to be coded. The R then indicates oversized OD, right?
Yeah. Yeah.
R1, 2, 3, and 4 then is 10, 20, 30, and 40 thousandths.
Correct.
And then the W indicates an undersized ID.
Right. Yep.
Okay. Yeah.
So
and
one other one that's not on here would be one with a suffix B, as in boy, and that means it has an OD groove. So sometimes an OD groove is necessary for the placement in the blocks. For instance, I think if I recall right, the old big block Chevys in the last position, it's kind of hard to figure out how to clock that. And so we have that with a OD groove, which means you don't have to worry about clocking it.
It's all the way around.
All the way around, yes, sir.
Even I knew that.
Isn't there some other bearings you offer that have a suffix that when the customer grinds a camshaft, and not necessarily, I mean, I'm sure there's some small block ones out there, but being that that's a more popular application, maybe not so much that, but for some of the V6s, the Buicks and stuff like that, there's actually some suffixes that are, like a 10,000ths on the ID to accommodate a grinding of the camshaft.
Right, and we have those other ones besides that as well. And so,
is the suffix a common denominator, like a single letter, or what, or how do you drive at that?
Right. So if you're actually looking for those types of ones, we have those in the back of the catalog under the bearing set contents. And for instance, back on page 68, it will show some different ones that may be. So, and those are by 10, and they'll be noted on that by that on the box. So it'll show you that it says by 10, by 20, and it actually denotes it as undersized ID. That'd be as, and that doesn't show in this particular one, but it would be noted on the box, and it's noted in the bearing set contents. You could pick out the one that you need to have to fix that part. I don't.
And maybe to Daryl's point, I don't know if this is possible, but maybe if you had like a quick reference guide to say, listen, if it's got these designations, this is what it means. Or not.
So in the back of the catalog, again, where it says bearing set contents,
right.
On the bottom, it has notes. The bottom says IND, which denotes undersized ID. And so you'll see that in each one of those show a 10, UND, or a 20 UND, or so forth. And what that's saying is it's undersized ID, and that's the note at the bottom of the page.
Oh yeah, I'm looking at that now. I see what you're saying. See what you're saying. Okay.
Does that make some sense? I know it's confusing, and the problem with cam bearings in general, unlike a lot of other parts, they're not just a plain bolt-on, right? The machinist is doing some fitting, whittling, whatever it is, to make these things work. And so there's a whole host of options to try to save that block, save the cam, and be able to get it down the road. So I'm sorry, board than add additional suggestions other than what we see there. More than happy to take those. Sure.
Got it, but those are some resources that will help.
Yeah. Okay.
Okay.
So okay to move on?
Oh, certainly.
Okay. So we also have the overhead cam repair bearings, and those are for those that have heads that get scored because they're running on the aluminum heads themselves. And so you can go through and bore that out, put a set of cam bearings in, and fix that head itself so it can be reused. We make that for a number of them, and we have those also listed in the catalog, and you'll see them on the side where it says that there's an overhead cam application under the application sets. So in the catalog itself, you got standard high performance nomenclature on the top, and then you have OHC, which would say it's an overhead cam, and the part numbers for that.
Got it.
Okay. So now we want to talk about GM. On that 2005 to 15, they had a number of problems with those engines, and a number of warranty problems out with them. So they came out and said, our suggestion is these should be a coated bearing. And so this is a bulletin put out by AERA, and it talks about the need for a coated bearing. Now, I know a lot of folks don't do that. They say it's too expensive, I don't want to do it, and they use other things instead. Not that it can't work, it certainly can, and it is, because a lot of those are sold and not as many of these, but that's the General Motors recommendation, just for information for your purposes to know what they're suggesting. Shows a number of different positions that are coded and the different designs, first design, second design, and these three would be RCH PT 10s and 25, 23s. So there's actually three different ones that would be in this type of thing. This piece here is about LS cam bearings, and it shows the particular ones that are available. So 99 to 2006, it's CH10 first design, and then the high performance that are available. The second design, which is the CH23, and the third design, CH25. Now, actually, the CH25 can be used in lieu of the CH23. The only difference between the 23 and the 25 is the 25 is a wider bearing. So it's, and as you see on the bottom, the little asterisk that says CH25 will work in place of the 23s. So just
and again, as a reminder, these LS products on the cam bearings appear on page 3 of the specials catalog under the LS performance parts section. And again, they're also detailed on that single sheet Dura-Bond LS engine parts guide. So we've got all of that coverage noted. Go ahead.
So this particular sheet shows, again, some things that you can use for a cam saver. We talked about before, if that cam has been polished too much, you can reduce the ID by the CH10 by 1, CH10 by 10 and 20. And same thing on the block itself. If the block needs to have something a little bit bigger on the OD, then you can also get that to be able to fix that as well. So actually, I have to go through this for a second with the block savers. They have to do some boring to get those to the size they want. If they want to change that out and save a block, shows you the positions have to be changed. And the sets that we have available to be able to fix that. So the machine shop would have to bore out those positions so that they could accept the larger ODs, but they can save a valuable block if they wish. And so another one of the enhancements that we have to try to figure out how to save a block, how to save the money, don't throw the block away. You can save the block, you can save the cam, you can get more oil, you can do, you know, everything we possibly can figure out to save the customer and the machine shop money by having the options available to them. This
Very
is
cool.
the brochure that you were talking about earlier. And it has, Bill's put this together with all the bits and pieces that we have. And you had that in one of your flyers. I don't know if it was a spring flyer, I think.
And the spring loop?
Yep.
Did we do this flyer in the spring?
Yeah, that went out with this last.
Yeah, went out with the last specials catalog.
Right. And so, and this is the back page to it. This has all the bits and pieces for the LS, the hardware we talked about in the video, all the pieces that need to be replaced. And again, as we talked a little further on about hardware, you know, that's a great piece to be able to put new stuff in, have it in a box, have a part number, be able to bill for it. It also has here the valve seats, which has that copper infiltrated. And those valve seats, as you'll see, has a C after it. And that C means it's copper infiltrated. So that's, and we also have some special shims that are designed for the LS engine. So there's a number of things on here, including some bronze bushing connecting rods that can be used to be replaced as well. So a number of things that we have, along with, of course, lots of other suppliers that do it in their own niche. These are some new sets that are available for the LT1 block. This was a block that was a problem with GM. Again, we put it together with them with a coated. That's what they wanted. It's a special one. You see that big dip in it. It's unique and made specifically to be able to take care of that. We do provide GM with a few part numbers for those fixes, like this one. Chrysler is another one. We had a couple of these engines that you couldn't replace the cam bearings in them. You had to buy a new block. So we redesigned them to make sure that we were able to get the right pieces in there. You'll see that wide piece of the cam bearing that allows this to be used instead of replacing a block. So another fix, trying to save people money and make it a quality product. We're going to go into valve seats. Any additional questions on cam bearings at this point?
Yeah, let's ask real quick. Folks, any questions on the cam bearings before we move along to the seats? Looking around, I think we're okay.
Okay, good. So powder metal valve seats. We make those here. This is a company we bought in 1996 out of Seattle. It was called Snyder. We moved it down here. We expanded it a lot from what it was at the time. And it's really a tremendous product. And fortunately for you folks, there is not another supplier in the marketplace that has these powder metal products in the range and depth that we do of different styles. So why powder metal? Well, powder metal is a metallurgy that is used in the valve seats and guides. It's a process that's used, and it's been able to take things up a step. So when you think about back to the days of drum brakes or disc brakes, you know, you take steps forward in technology. When you look at carburetors and fuel injection, another step in technology that moves forward. And so just another one of those steps used by OEs across the world, powder metal, to be able to move forward in technology improvements. The cast ones have been around forever. Doesn't mean it's a bad product. It's a product that's sometimes more reasonable, a little bit, not a lot, but a little bit. So I understand, you know, people still use that, and so it's just a choice in some technologies as you move forward. So again, with the OEs, this is just a step to get tighter tolerances, smoother finishes, better performance than ever before. They're always worried about the engines and going forward, the new performance, the mileage, emission levels. So a rebuilder can restore the performance to like new using these type of products. And so it's, again, just a step forward in technology. And the powder metal is a process, not a product. It's a mixture of a lot of metal components. So what we do is you take bars of steel, they're atomized, meaning they're put into a powder form, and then they can be mixed to create a uniform model that needs to be able to make things come together. You can put a pinch of this and a pinch of that. It's kind of like doing a cake, and you have complex alloy in it.
But that
yes,
process is called atomization?
It's atomized, yes. What it does is it takes the steel and it makes it into powder.
That's awesome. Thanks. Atomized.
Yep. So the structure of a cast seat is a bit irregular, and it's irregular because you're pouring, and we used to make these too. You're pouring hot molten metal into a form, and with that, there can sometimes be voids because you get gas pockets, and you can have uneven distribution of alloys. With the powder metal, it's different because it's mixed together, blended with a whole lot of different materials that go into it. It would have free graphites in it for lubrication. It'll have tungsten in it. In some ways, like the copper infiltrate, would have copper that'll go into it. So it has lots of things that can be put into it, and it's put in a press, powder metal press, and as powder, and then it's compacted at 100 tons. And at 100 tons, it comes up as a net-shaped part. So as a net-shaped part, it comes up and it does not need to have all the machining that the other one does, and it has a consistent system throughout it. So here's, yes, sir?
I said, got it.
Okay. So here's a little picture of a powder metal. That little dot in the middle of the powder metal is a 1,000th little dot. On the cast side, you can see as it's poured, it comes out in a variety of different ways in the hot casting thing. So it's a different technology, and it's something that is, like I say, an older technology that OEs and others have moved on from. Not that it won't work, it certainly has worked over the years, and it still has possibilities. But like other things, there's a movement to move forward and find better products.
Hey Chuck, I got a question. So the powdered metal, are you buying that raw product already in the powder? Or are you taking the raw product and shaving it down into a little powder, and then that's what you use?
We buy the powder. We buy the powder from professional people that make it for OEs, and then we buy it in different types, and then we bring it in-house, and we blend it in a mixer here in-house to our blend, and then it goes into the press. So we do not atomization process. We get that already done.
Cool.
So in the fit of all this, you want a precision fit, of course, and you want typically 1,000ths of the run out, and the cast seats can be 3 to 5. And the only reason I say that is that the powder metal comes off in a real fine chip that's all consistent around. On a cast one, you're pulling off a curly string, and what it's doing, it's kind of ripping that material out of the seat, and if there's any hard spots or there's any voids or other things, it can make it possibly somewhat more difficult to maintain that run out. So the consistency, internal consistency of the powder allows you to get a more precision fit. Some people will say, oh, powder metal, that stuff breaks or whatever else. I've heard of it breaking in an engine, and that's a problem, and so forth. So we'll talk about that a little bit further. But they're very strong, withstands repeated impact, lightweight, which doesn't mean a big deal in a head, but they're used in lots of things. Most of the cars today, like new Corvettes, use powder metal connecting rods. So it's not that it's not strong, it's strong, as strong as anything could be. Other piece that's important is the lubrication, and the lubrication is be blended into it, which reduces friction. So if you've got a guide or you've got a seat and you're trying to get the emissions down tighter, then part of doing that is to be able to take the oil out and use something else to lubricate. So in that lubrications, you have things like graphites, and the graphites can be part of the powder, so you can tighten the clearances and help eliminate emissions. Can't do that in a cast seat because gas is poured molten metal, and it takes all those kind of things away. You just can't have it in a powder metal seat where it's pressed cold. So it also has some better heat transfer. It'll be able to absorb the heat. It's used in almost all the OE applications. So it's got different thermal loads changes, containing a tighter seal. They're more effective in removing heat. And so one thing I use in the bottom here, which kind of funny, I think, but you know, lots of times you look at things and you say, okay, well, that's a valve seat, it's a ring, the other one's a ring, they're a ring, who cares? It's just a ring, you're gonna pop it back in. But if you look at it in a different way and you say, okay, Mr. Machinist, you've got one piston that's a problem with your race motor, they're all dome pistons. Could you put a flat top piston back in? And will it run? Of course it'll run. Would you ever do that? No, never, right? So the same thing is a little bit similar with valve seats. So most all the valve seats that come from the OEs are all going to be powder metal seats. So if some guys are changing just out a few, 1 or 2 or 3 or whatever else it may be, and they may be popping in a cast seat. The cast seat has a bit different heat transfer than a powder metal seat. So much like the more visual look of a flat top piston, you could be doing that same thing by putting in 1 or 2 cast seats that doesn't have the same type of heat transfer as does a powder metal seat. So I suggest that if they're even just changing out a few, they put in like type of product that would be helpful to make sure that that continues on the way it was designed.
Got it.
Does that make sense?
Does to me.
All right. One yes.
Everybody else is nodding.
They're nodding.
Yeah, they're all nodding.
I hope they're not nodding.
No, they're not nodding off. They're just nodding.
Okay, good. So the other thing that's important is micro welding. And so if you're using a seat, particularly for LPG, propane type of applications, it needs to be a piece that will not weld. And the problem with welding with a seat is that any of the LPG type applications, they don't have lubricants in the fuel, so the fuel is running without the lubricants to keep it from micro welding. So with Dura-Bond, we have a formula that allows for putting oxides into the seats. That is primarily in the 70,000 and 90,000 seats. They have oxides into them, so you can put those in a LPG or standby generator type of applications, and they will not weld. And that's the key for making any type of product for those fuels that have no lubricants in it, no micro welding. So these are the 4 different series we have. The 3000, which is basically for an unleaded fuel. The 90s and 70s are for dry fuels and extreme duty. We provide to those 70s and 90s for a lot of heavy-duty truck. So we provide those to some significant names in the aftermarket that are using it for the Class 8 Cummins, Detroit, Cat, etc. And we do those overseas as well. And then we come to the Killer Bee seat, which we talked about briefly, which is more the LS and other things that are causing difficulties with getting heat transfer out of the engine. So one thing that happens with the powder metal seats, they actually work harden a bit. So when they're first done, they're a little easier to machine, but it helps with the tool life, greater productivity. After installation, they'll be a bit harder. So when the guy comes in with a head that's been being rebuilt, they'll find that those are a bit harder seat. And the good and bad is they last really well, so they don't change out nearly as many as we did in the old days. That's the good and bad.
Yeah.
So here's our little Killer Bee guy, and Bill Dolek and I worked on this for a while. We call him Buzz. And so a little funny story with it, trying to come up with a little marketing PR to it. We knew that the engineer for GM called his new seats with a copper infiltrate the killer seats. That's what he called it, the engineer did. And the guys in the South, and some of you are down close to the South, if you're in Memphis, etc., some of those guys would call up and say, you know, I want those copper beryllium seats. But they didn't really say that. They said, can you send me some of them Yeller seats? Well, give me a little bit of Yellers, right? So this is our little funny of coming up with killer, meaning the GM guy said these are killer seats, and the little bit of we call it a honey hue. So it's a Killer Bee. So that's a lot of marketing that went into that one, believe me.
Yeah, it's awesome. It's going to be a big seller down in Oklahoma.
So anyway, little side story. So on the Killer Bee, again, this is for the LS3. They couldn't get the heat out. They also use these in Mercedes, BMW, etc. What we do is we make the powder metal seat, and then we put a little copper wafer on top of it. After it's done, it goes through the furnace, and that furnace will infiltrate into the pores of the seat, because it's a bit porous, 15% free copper into the microstructure, and that'll allow the heat to be quickly transferred out and the performance greatly improved. And that's the only way GM can make this thing engine work. And the good news is you got them. So there's a little copper wafer before it goes to the sintering furnace. So it goes on there, it goes through the sintering furnace, and all that copper will infiltrate into the seat itself. So, as I said, we have that as a series, and this is the quote from that engineer that designed it. This is a killer LS3 copper infiltrated exhaust valve seat. And it's mainly the exhaust is the problem. It's trying to get it out of there. So that's how we came up with a brilliant marketing strategy.
It is exactly that.
So offers superior thermal conductivity. It machines really well, has thermal expansion, lowest wear, superior surface finish, that's suitable for heavy-duty intake, exhaust, gas, and diesel, and compatible with most all valve materials. This is an article that was done by the Engine Professional magazine, and this is a problem that goes on and on and on with your machine shops. They have problems with the valve seat failures on the 37, 47, 57, 61 Chryslers. And the problem with that is the same one that the GM had. And they'll say, oh man, you know, I don't know what to do with these things. Well, the problem is they didn't have enough press fit for the seat. They didn't have enough depth in the seat, and they didn't have the copper infiltrate. So Chrysler, which has contracts with AER in Texas, it's worked with them back and forth, and the solution was to come up with copper infiltrated seats that would be deeper, more press fit, and have copper infiltrated in it to get the heat out. When you do that, it fixes the problem. But without that, these seats are dropping out. Any machine shop you go to will say it's a nightmare, and so that's the only fix to it. So once those seats drop out, they drop out in pieces because they drop out and then they start bouncing around in the cylinder. And once they bounce around in the cylinder, then that part is a problem. It also gets up, I think, into the plenum. And so if you don't clean that out as well, those particles are caught up in there, and then they'll be dropping back down, and you'll have another problem. So that has to be cleaned out or replaced, and then the right seats in with the right press, the right depth, and the copper to make it work. A real big problem. When I show this to different machine shops and others, they say, thank God, geez, this is a fix. I don't even want to look at these things half the time. So, like inside when it starts to drop about, and this is a piece that perhaps you might want to try to see if we could get that copied for you. Greg, maybe you could do that to the folks somehow, and if you show that to your guys, they'll say, okay, wow, that's it.
Yeah, that's a great thought. Or Chuck, if you had a PDF, we could share it with the folks electronically. Probably be the easiest way to do it. But
right.
Either way, we'd be happy to do that.
Yeah, okay. We've got a PDF we can do, no problem. So these are other advantages of being able to have a powder metal seat. You can put the right product inside it. You know, if you're doing this with a cast, maybe there's a fix, but it's not the same, and it doesn't get it fixed the way that the OEs and other people are suggesting is the right way to make this thing work. So that's pretty much
and Chuck, it. About 10 minutes, so we've got about that time to move through the remaining stuff.
Yep, and it's going to go. The rest is going to go quicker. So we have valve spring shims. We make all those in our plant. They're all done here. They're coated. They're a flat shim, no serrations to them. Serrations on aluminum heads can obviously damage the pads. We have the hardware. A number of different things with hardware. Another opportunity. You got lots of guys that have places that look like this, and the guys will say, gee, how do I make more money? Well, maybe you don't want Harry for somebody to be sorting through all this stuff, finding the parts, and then they're still used. When he gets done sorting them out, we have them in finishing kits. They have them in a package with a part number on it. The guy says, how do I make more money? Well, how about not having Harry sort the stuff out? Why not give them all new? Why don't you have it with a part number? The part number you can put on a bill of material, and believe it or not, you get charged for it, and maybe you make a little more money. What a novel idea. So we have all those. They have ones like the ones you see here, all brand new, all ready to go. Charge it out, make some money. No need to keep running back and forth to the dealer for the pieces. As well as they can all be ordered individually. So we have that either in a kit or individually. A little instruction sheet to show where they are and where they go. So it's not a question, that's in the box. Here's some of the different ones, and there's lots more available. We showed the LS ones previously. We have some spark plug tubes where they need to be types of things fixed. Powder that we get in for the powder metal.
Oh, okay. That answers that earlier question, right? So in other words, that's bags of powder.
Yep. This is a brand new powder metal press, $400,000 press. Some older presses we have. This is the blender that mixes the powder. All the tooling, because they all need individual tooling for every seat. The sintering furnace, how that goes through. Steamers and oxide things to make the oxides. Another furnace. This is a seats lined up to go through the sintering furnace to be put together, make them hard, grinding, so forth. More tools, marking. We mark all of them, and we put them in a solution to make sure that they're won't rust. Grinding.
Santa Claus?
Land from the back. One of the culprits, I don't know where he's going. Maybe he's trying to make a break for it. Other pieces we have of machining and the CNC, lots of CNC equipment that are in here. And then we'll do quickly, Bill is coming up with some new things soon.
Yeah, so I know we're short on time, so I'll go through this really fast. Anyways, upcoming soon, probably within the next 30 days, we'll be going to print for the new upcoming catalog. I know everybody's been waiting for it. We've changed it up a little bit this time. Instead of just a generic catalog, we decided to hit 4-color throughout. We have all kinds of, basically kind of see how we, like these are all the aftermarket blocks. We have product highlights, so all the new stuff is going to have a picture of it, a description of it. It's also going to be in the listing, but like I said, we kind of show them off a little bit with the product spotlights. You can see here's some of the stuff on the hardware. We also, you guys seen the LS parts guide, it's going to be in there. We also have the Hemi parts guide now, and within that, we are going to be offering the new Hemi finishing kits, components for it, the bearings, valve seats, just like the LS one. Like I say, all this will be out in about a month. The other thing that we got up and coming is we'll be launching our new website within probably the next 30 days. It's going to be sent out in 2 phases. I just took a fast couple of screenshots. It's still in progress, things like that. But this part of it, you can see we have, on the about, we got history. We're going to have the bios. We're going to have a photo gallery in there. We got stuff on engines. We've added all our transmission line in there. You can request a quote under resources. It's going to have the frequently asked questions, downloading of all of the catalogs, including the Hemi, the LS stuff, all that stuff. We got product flyers. We're going to have all kinds of videos in there, new announcements. Every time we put up a new thing, it's going to go in there. We also have where you can, contact us. You can contact any of the warehouses. You can contact any of the reps. All of that's on maps, employment opportunities, credit apps, things like that. The other thing, you can sign up for updates to get our monthly, as new things come about, stuff like that. Language across the world. It doesn't matter what country you're in, what language. You can just click on select language and it'll change all that stuff. The other part we're doing is the part search lookup. We've spent over 500 hours in design time already creating this new thing. The thing is going to be incredible. I don't have any pictures of it yet, but trust me, it's going to be great. That's going to be on here. And in phase 2, eventually there'll be if you're a customer, there'll be a login. And at that point, eventually you'll be able to log in, check inventory, pull your price sheets, place orders, check status, invoices, all that stuff. That's phase 2 of this site. But pretty much that's kind of some upcoming things we got in the next few months.